We've been looking at the Kalam cosmological argument for God's existence, and last time we began studying the philosophical arguments and the scientific confirmations of the crucial second premise that the universe began to exist. We looked at Ghazali's first philosophical argument based upon the impossibility of the existence of an actually infinite number of things. But he has a second philosophical argument as well. And before we turn to that, just let me make sure that there's no residual question concerning the first argument before we move on. Is there any question that anyone has concerning that first argument for the finitude of the past? All right, let's move then to the second philosophical argument. This argument is independent of the first argument. That is to say, even if you think that an actually infinite number of things can exist, this argument aspires to show that the series of past events, at least, cannot be actually infinite. Now, the series of past events, Ghazali observes, has been formed by adding one event after another. The series of events in the past is like a sequence of dominoes falling one after another until the last domino today is finally reached. But, he argues, no series which is formed by adding one member after another can be actually infinite, for you cannot pass through an infinite number of elements one element at a time. Now, I think this is easy to see in the case of trying to count to infinity. No matter how high you count, there is always an infinity of numbers left to count. And therefore, no one can count to infinity. He can go on and on and on, and infinity will simply be a limit to the series of numbers he counts, but he will never arrive at infinity. But if you cannot count to infinity, how can you count down from infinity? This would be like someone's claiming to have counted down all of the negative numbers ending at 0, -3, -2, -1, 0. And that seems crazy. For before he could count 0, he would have to count -1. But before he could count -1, he would have to count -2. But before he could count -2, he would have to count -3. And so on, back to infinity. Before any number could be counted, an infinity of numbers would already have to have been counted first. So you just get driven back and back and back into the past so that no number could ever be counted. But then the final domino would never fall if an infinite number of dominoes had to fall first. So today could never be reached. But obviously here we are. So this shows that the series of past events must be finite and have had a beginning. Any question or discussion of that first or that second argument for the finitude of the past?
I understand the argument, bro, I think really well, but what are the objections to how someone can say, like the atheist says, how do you reach like a past infinite events to now?
Honestly, I've read the responses to the Kalam cosmological argument, and I can't think of any atheistic response to this as to how you could count down an infinite number of events to arrive at today. Sometimes, here's a response that is sometimes given, and I think we've already encountered it. They will say, well, look, any negative number you pick is only a finite distance from 0, right? Whether it's -3 or -10 trillion or whatever, any negative number you pick, it's only a finite distance to 0. So you could count down from that number to 0. Now, if you have an infinite number of negative numbers, you can count down to 0 from every one of them. So if from every number you could count down to 0, if that's only a finite distance, then it follows that there's no problem in counting down an infinite series. And as I said last week, that clearly commits a fallacy called the fallacy of composition, which is saying that because a part of a thing has a property, therefore the whole thing has the property. And a classic example of this fallacy would be to think because every part of an elephant is light in weight, therefore the whole elephant is light in weight. That is obviously a fallacious inference. You can't reason because a part of something has a property, therefore the whole has the property. Now similarly, in the series of negative numbers, every part of the series is only a finite distance from 0, and so could be counted down. But it doesn't follow from that therefore the whole series can be counted down. The objector has clearly committed the fallacy of composition, and the question is not how any finite part of the series can be traversed or counted. The question is how the whole infinite series could be traversed or counted. And that just isn't answered by this fallacious sort of objection. Eric.
This is something that's actually sort of bothered me as a physicist and an astronomer, and feel free to tell me this is a tangent, but current models of the universe would say that the universe is flat. Therefore, according to the principle of homogeneity, it has no edge, so it goes on for infinity, but it would have started from the Big Bang as a mathematical point, so it went from size 0 to size infinity. So,
yeah, that's a real problem. I've asked cosmologists about that, and it's very difficult to make sense of that. Now, I think what many would say, and what I would say, is that the universe is not, in fact, flat. It's not like a Euclidean plane that goes out to spatial infinity. Rather, space is curved like the surface of a sphere. And on the surface of a sphere, there is no edge where you're going to fall off. But what will happen is if you go far enough, you just come back to where you start again. And so if three-dimensional space is like that, then there's no problem in it having this sort of beginning and making this magical leap, as you say, from a singular beginning point to infinite size. That's just avoided by saying that the universe is spatially finite. So that's a good question, not tangential.
Doesn't Stephen Hawking try to curve off the bottom of the light cone to avoid this idea of a beginning of time? I've never understood how that avoids it, because even if it's a curve, there's still a bottom point. There still seems to be a
Yes. What Kevin points out, and we'll talk more about this when we get to the scientific confirmation of the beginning of the universe, is that if we let this disk represent our three-dimensional space, as you go back in time, space shrinks down to a singular point, which is a boundary or an edge to space and time. In Hawking's model, he does some mathematical tricks to eliminate that beginning point and round off the beginning. So it's sort of like a southern hemisphere of the Earth, or a badminton birdie. It doesn't go back to a singular point at which you drop off the edge. Rather, if you go back, as I say, as on a sphere, you just keep going and you'll go right around, right past the South Pole. The South Pole on the Earth is not an edge or a boundary where you fall off. If you go south and you go through the South Pole, you just start going north again, and there isn't any boundary point. And as Kevin says, Hawking mistakenly thinks that because in his model there isn't any boundary point, that therefore there's no beginning to time and the universe. I'm actually letting the cat out of the bag for my talk that I'm going to be giving at the EPS conference in November. But Kevin is quite right in saying, or pointing out to us, that on Hawking's model, time here, which is the vertical dimension, is still finite. The universe has not existed infinitely into the past. It is finite and has a beginning. It just doesn't have an edge or a boundary point as a cone does. Now, I have to say that in his most recent book, The Grand Design, co-authored with Leonard Mlodinow, Hawking does admit, Kevin, exactly what you said, that we can let the lines of latitude represent time. So that as you go back in his model, he says you finally reach the South Pole, and this is the beginning of the universe. It is the beginning of time and space. And so he actually admits exactly what you're saying. It doesn't have to be a boundary point or singularity in order for it to be the beginning of time and space. We'll talk more about that when we get to the science. Any other question about the philosophical argument that al-Ghazali is offering here against the possibility of traversing the infinite, as it's sometimes called, or forming an infinite by successive addition? Let's see, I think I saw a question over here. Yes, Taylor?
So I was just curious. I know that you distinguish eternity for God and time within our world, or in the universe. Can God count outside of the universe? Or I don't know if you answered this last time. I just came back.
Well, let's recall our discussion of the attributes of God when we talked about divine eternity. And remember we said that the core concept of eternity means to be without beginning or end, something that exists permanently. But we saw that you could do that in two radically different ways. One would be to endure throughout infinite time without beginning or end. The other way would be to be outside of time altogether, to transcend time, to be timeless. And theologians have typically thought that God is eternal in the sense that he is outside time. But when we're talking about the universe being past eternal, we don't mean the universe is outside time. We mean that first model extended throughout infinite time. So the question is, can the universe be past eternal in that sense of going back in time to infinity? That can there be an infinite number of prior events before today?
Yeah.
Does that answer the question?
I think it's getting there, but
Okay, yes, it was getting there, but it didn't answer it. So can God count
yes,
infinitely? Yeah. I would say that insofar as God is in time, and my argument, you remember when we talked about his attribute of eternity, is that God is in time with the universe, that once time comes to exist, God enters into time in virtue of his real relations with his created world. So God could start counting at the moment of the Big Bang, and he would then count forever, but he would never reach infinity, because you can't count to infinity. That's metaphysically impossible. Any finite number you count plus one is always another finite number. And that's why you cannot reach infinity by counting one number at a time.
So prior to the existence of the universe, God wasn't able to count?
Okay, the question was God able to count prior to the beginning of the universe? I would say yes, he was able to count. And in that sense, had he been counting, time would have started prior to the Big Bang. Okay. We could imagine God leading up to the moment of creation by saying, 3, 2, 1, let there be light. And in that case, you would have a succession of mental events prior to creation. So, yes, he would be able to be counting. But I would say that not even God could count down from infinity past, because that's metaphysically impossible.
All right. I was wondering if you were going to address objections where someone offers a hypothetical scenario. A widget is able to make a copy of itself in a half a second, then in a quarter of a second, eighth of a second. And so, any time before 1 second, it's finite. Once you're past 1 second, it gets infinite.
Yeah.
And presumably weirder and weirder as you go beyond 1 second.
Yes. Oh, all right. Now, what Drew is alluding to is the claim of some philosophers that there are things called super tasks. And that is that you could form a collection that is actually infinite by doing it faster and faster and faster. So you could imagine a machine, say, that moves a marble from one tray to another, and it moves the first marble in 1 minute, then it moves the next marble in 30 seconds, then it moves the next marble in 15 seconds, and the next one in 7.5, and faster, so that after 2 minutes, all of the marbles would be transferred, and it would have completed an infinite number of tasks in a finite amount of time. And I would argue, Drew, that this sort of idea of a supertask is, again, metaphysically impossible. Now, how do I explain this simply? Well, let's oh boy, let's use the letter omega to symbolize that process that's going on of transferring the marbles, okay? Omega is an ordinal number of infinity. Now you say, well, wait a minute, I thought that the number of infinity was Aleph 0, the Hebrew letter Aleph, that was the number of infinity. Well, to be precise, that's the cardinal number of infinity. What is the difference between cardinal numbers and ordinal numbers? Cardinal numbers are numbers like 1, 2, 3, 4, 5. Those are cardinal numbers. Ordinal numbers are numbers like first, second, third, fourth, fifth. The cardinal numbers tell you how many things there are. The ordinal numbers tell you the order in which they are. First, second, third, fourth, fifth, okay? So, the order type of infinity, the ordinal number for infinity is omega. Now, after you have completed the transfer of the marbles, you have a new state. The marbles are all now in the left-hand tray, whereas when you began, they were all in the right-hand tray. And so that would be the state designated by omega plus 1. All of the states transferring the marbles were going on during the omega state, and now you're done. That's omega plus 1, the state that's after the process. And notice here that there is no last number or member in this omega series. There is no last marble that gets transferred from the right to the left because it's just infinite. What that means is that the state that exists at omega plus 1 is completely indeterminate with respect to the omega series. It would be a causal gap in nature. One philosopher who discussed this used an example of a light that is turned on and off faster and faster and faster and faster. And his question was, at omega plus 1, is the light on or is it off? And the answer is, there isn't any answer, because the state of the lamp at omega plus 1 is completely unconnected to its state during the omega series. Now that may be fine mathematically or on paper, but in reality, as I say, that means there's a sort of hole or a gap, a causal gap in nature where the state of the lamp at omega plus 1 is completely unrelated to the series of turning it on and off, or where the state of the marbles at omega plus 1 is unrelated causally to the state of the marbles during the series. And so my argument would be that, again, this kind of supertask is metaphysically impossible because there is a causal gap in reality on this model that makes no metaphysical sense. Now, of course, in talking about whether you can have an infinite number of past events, we're not talking about doing an infinite number of things in a finite amount of time. We're talking about a series where all of the intervals are equal, right? An infinite number of years, or an infinite number of seconds, or an infinite number of days. There is no faster and faster and faster. So in one sense, this question is purely academic because it doesn't apply to the series of past events, which are all equal in duration. And there, you can't appeal to this speeding up in order to get the job done. Okay, as you can see, these arguments are just sort of the tip of the iceberg that leads into fascinating, fascinating discussions. Any other question on this second argument? All right, now al-Ghazali sought to heighten the impossibility of forming an actually infinite past by giving illustrations of the absurdities that would result if you could form an actually infinite past by adding one member after another. So he says, let's imagine our solar system, and here is Saturn. And let's imagine that for every one orbit that Saturn completes around the sun, Jupiter, which is closer in, commits or completes 2. So for every one orbit that Saturn completes around the sun, Jupiter completes 2. Now, notice that the longer they orbit, the further Saturn falls behind. If Jupiter has done 10 trillion orbits, Saturn has only done 5 trillion. And the longer they orbit, the farther and farther Saturn falls behind. If they continue to orbit forever, they will approach a limit at which Saturn is infinitely far behind Jupiter. Now, of course, they will never actually arrive at this limit, but nevertheless, they will approach this limit the longer they orbit. Now, let's turn the story around, says al-Ghazali. Suppose that they have been orbiting the sun from eternity past. Now, which one has completed the most orbits? Well, the answer mathematically is that the number of orbits completed is exactly the same. They have both completed just infinity, an infinite number of orbits. Now, notice you can't get out of this argument by saying that infinity isn't a number, because it is a number in this case. We're dealing with an actually infinite number of orbits. And so it is a number. In mathematics, infinity is a number. In set theory, at least, it's the number of elements in the set of natural numbers, 0, 1, 2, 3, 4. So, if they have been orbiting from eternity past at the rate of 2 orbits of Jupiter to every orbit of Saturn, they have now both completed the same number of orbits. But that seems absurd, because the longer they orbit, the more the disparity between them grows. So how does the number of orbits magically become equal just by having them orbit from eternity past? Any discussion or comment about that argument from al-Ghazali? And as I say, this is his argument in the 12th century. It's just amazing to read this stuff. Here's just one more little juicy tidbit about this illustration. Al-Ghazali asks, is the number of orbits completed odd or even? And you know what the answer is mathematically? It's both. It is. It's both odd and even. So that, again, I think just shows the absurdity of trying to form an actually infinite number of things by successive addition. Here's another illustration. Suppose we meet a man who claims to have been counting down from eternity past, and he is now finishing. -3, -2, -1, 0. At last. Why, we may ask, is he just now finishing his countdown today? Why didn't he finish it yesterday? Or the day before that? Or the year before that? After all, by then, an infinite amount of time had already elapsed. So, if the man were counting, say, at the rate of 1 number per second, he's already had an infinite number of seconds to finish his countdown. He should already be done. In fact, at any point in the infinite past you pick, the man will already be finished with his countdown, which implies that no matter how far back in time you go, you'll never find the man counting. And that contradicts the hypothesis that he has been counting from eternity. So this again, I think, shows the absurdity of trying to form an actual infinite by adding one member after another. Any discussion of that illustration?
Hope I can remember this well enough, because I know that guys like Wes Morriston will say that the point you made about why, when you ask why hasn't he finished counting down, yesterday or the day before that, they'll try to say, well, that's a non sequitur. Just because we can't postulate a reason for why they haven't finished their countdown doesn't mean there isn't a reason for it.
Oh, I think it's very clear that there cannot be a reason for finishing today rather than tomorrow, or finishing today rather than yesterday. There simply isn't any reason that could be given why one point in the past would be the point at which he finishes. I think what someone like Morriston would rather have to say is, well, there doesn't need to be a reason. It just is that way. And that would be an acceptable response, but I guess what I would say in a case like that is that given an infinite amount of time, that's a sufficient condition for finishing his countdown, and that therefore he should be done by now.
And then I know what he says to that, though, is he'll say something like, but isn't there a difference, though, between counting down an infinite amount of the past versus all of the past, right? Like, because isn't it possible somebody could have counted infinitely but still not have gotten to the present, because isn't there a difference between the two?
Yes, now that's a good point. There's a difference between counting all the numbers and counting an infinite number of numbers. But in this case, it would seem to me that if you're counting at 1 number per second, you would finish counting all the numbers. There's no reason as to why you would finish tomorrow rather than today, or yesterday rather than today. So that having an infinite amount of time would be a sufficient condition for counting all the numbers in the negative number series. Yeah.
It keeps going around in my mind of if he had to have a finish, where and when would he have begun in the first place?
It's important to understand that he did not have a starting point. Just as the series of as the series of negative numbers has no beginning point. There is no largest negative number. So the series of past events in a beginningless universe would have no beginning point, which makes it all the more unintelligible. I think it's, for him to arrive at today is kind of like trying to jump out of a bottomless pit. Right? Think about that. There isn't any beginning point, whereas to get leverage, so to speak, it just sinks into an infinite regress, and it becomes unintelligible how the man could get to any point in the past, I think.
When I'm thinking about this, something comes to mind is, can God make a rock so big that he can't lift it? Is that analogous to the question that can God cross? Can he traverse an actual infinite?
Right. What you're saying is that that's a logically impossible task or a metaphysically impossible task for God to do, and therefore it's no infringement on his omnipotence. And similarly, al-Ghazali and I would say these are metaphysically impossible things, and therefore it's no infringement on God's omnipotence that he couldn't do such a thing. Now, it's always encouraging when one's philosophical colleagues express support for an argument, and you've managed to make some impact upon the territory. And therefore, I've been tremendously encouraged that 2 very brilliant and gifted philosophers, Alexander Pruss of Baylor University and Rob Koons of University of Texas at Austin, have recently both defended a very engaging contemporary version of Ghazali's argument. And this is called the Grim Reaper paradox. Imagine that there are infinitely many Grim Reapers who are bent on your destruction. And we can identify these as gods so as to forestall any physical objections. Suppose that you are alive at midnight, and that Grim Reaper number 1 will strike you dead at 1 a.m. if you are still alive at that point. But Grim Reaper number 2 will strike you dead at 12:30 a.m. if you are still alive at that point. But Grim Reaper number 3 will strike you dead at 12:15 a.m., and so on and so on. Now, such a situation seems clearly conceivable given the possibility of an actually infinite number of things. But it leads to an impossibility. You cannot survive past midnight. But you cannot be killed by any Grim Reaper at any time. You can't survive past midnight, but you cannot be killed by any Grim Reaper at any time because you would already be dead first. So, Proust and Kuhn show how to reformulate this paradox so that the Grim Reapers are spread out over infinite time rather than over a single hour. For example, you can stipulate that each Grim Reaper will swing his scythe on January 1st of each past year if you have managed to live that long. And you'll get the same sort of paradox. You cannot survive to the present, and yet you cannot be killed by any Grim Reaper at any time. So this shows, again, the impossibility of an actually infinite past. Well, think about that until we meet next time, and then we'll bring up any questions that you might have at that time. Let me just conclude by saying that these illustrations, I think, go to strengthen Ghazali's claim that no series which is formed by adding one member at a time can be actually infinite. Let's bow for our benediction. Grace to you and peace from God the Father and our Lord Jesus Christ, who gave himself for our sins to deliver us from the present evil age according to the will of our God and Father, to whom be glory forever and ever. Amen.